talk about MapReduce. We have seen how to install Hadoop, what are the popular Hadoop commands you use in your cluster, right? And now once everything is done, let's start understanding this MapReduce framework, okay? We know that we know how to upload a file in SDFS, right? And then why did you upload the file in SDFS? Because you want to process it, right? And when you want to process it, there are so many ways to process that file. Today we are going to talk about one important topic like MapReduce, which can be used to process that file, okay? Now for our understanding, what we will do is we will try to process a file, okay, which has some words in it. So let's say you have apple, ball, apple, 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 ball, ball, apple, ball, 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 and apple. Now let us assume these are two files which are present in your SDFS. So this file is called as word1.txt and this file is called as word2.txt. So let's say you have two files, word1.txt and word2.txt. We have word1.txt, we have word2.txt, right? And this file is, let's say, present in your SDFS location. And now we know what is the SDFS location, right? So suppose this was present in your Ubuntu. Okay, so in Ubuntu, on your desktop, you had this file. On your desktop, you had these two files, right? And what you did, you said Hadoop fs-mkdir, you said word_files, for example, and you created a folder and then you uploaded these two files, right? You said Hadoop fs-put, what to put from your desktop, your word1 and word2, where you want to put? You want to put it under this word file. That's what you did, okay? And you have word1 and word2.txt uploaded in your location, right? So what is the location of these two files? These files are present here, /user/hd user /word_files, okay? Done. Now what we want to do is we want to process this file, and our objective is very simple. Our objective is write a program to count the frequency of each word. Now what is my expected output? Let's also understand. This is my input, this is my input, right? And my expected output is apple. What the occurrence of this apple? 1 2 3 4 5 6. And let's say the occurrence of ball, 1 2 3 4 5 6. This is what we are expecting, okay? So let's confirm this. 1 2 3 4 5 6 7 8 9 10 11 12. So 12 total words, apple 6 times and ball 6 times. This is what is the output we are expecting out of this program, okay? Now what we will do is we will have to write a code, and that code is basically a MapReduce code. So in a typical MapReduce program, what we will be doing is we will install Eclipse, right? I assume that we have already installed Eclipse. In Eclipse or IntelliJ, whatever is your comfort, okay? We'll install Eclipse or IntelliJ. There we will create a Java project, and inside that Java project we will have certain resources like I'll have source, main, Java. Under this we will create our mapper code. We'll create a package called in.olc, okay? And inside this package we'll have a class called myMapper. I'll have a class called myReducer, and I'll have a class called myDriver. And these are all .java files. Now once you have created this project, let's say the project name is my word count MapReduce, okay? And this is basically a Java project. So we would create exactly the same structure wherein we will write our code, right? Now once this code is written, we will bundle this into a jar file with the name my word count.jar, and we will execute this jar file using a command Hadoop jar, okay? Some parameters which we will see in our coming days. So this is what we want to do in our first program, right? So let us talk about this mapper and reducer theoretically today, and we will implement that from scratch in the next class. All right, so now we understood what would be the structure of the program, right? But then let us try to understand theoretically the concept of this mapper and reducer. Do not get confused with two files, okay? And what I will say, let us not even talk about this one file. Let's assume that this one file is not even there. Okay, so one rule of thumb is to process any big data job. Okay, so see, I'll tell you the formula of becoming a successful data engineer. The formula of becoming a successful data engineer is, don't think about too many files, just think about one file, write a logic around one file, and everything else will fall in place. Okay, you should not, like when I was learning data engineering, this MapReduce and all long back, I was also confused like you, like what should I have in, how do I even process 10,000 of files, and I was not able to write a code so efficiently. But then I changed my thinking process. I said, okay, just think about one file and everything will follow, right? Everything would be same. Okay, so let us not even talk about two files. Okay, I'll make it a little simple. Let's say we have only one file for now, word1.txt, right? But then the same code will work as it is even if you have 10 files, it does not really matter. So I have one file, okay, only one file with three lines. Okay, now what you'll do is you will write your mapper code. Java class, okay, where you will have a map method, and in this map method you will get key, you'll get value, and you'll get one thing called context. What are these? We will learn in great detail. Okay, but then theoretically, let us try to understand this today. So this is your mapper class, mapper.java, mymapper.java, wherein you have a method called map method. And what does this map method do? This map method will get the data in form of key and value. Okay, for example, this is your file. This file actually would be converted into key value pair. This file is basically what? Lines, right? So this file has a lines, 3 lines, right? So these 3 lines will be converted into key value pair. The first one would be 0, 0, okay? And then apple, ball, apple, right? Second line, again see here, you had 0 here. Now how many characters you have? See here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You have 16 characters altogether, right? And probably one slash and also. So let's say 17 characters are there. So 0 plus 17 is how much? 17 would be the key next time. Okay. And then again you have apple and ball. Apple and apple. Now how many characters are here? 1, 2, 3, 4, 5, right? Again, this is also 5. 5 plus 5, 10. 1 space, 11. And let's say one slashing is also there, 12. So 17 plus 12, how much? 29, right? That would be the next key. Again, you have a ball and you don't have anything. So this file will be converted into key value pair like this. You have given a raw file. You did not give the key value pair file. You gave a raw file, and that raw file was converted to key value pair. Okay, that's how the framework does. Who does that? We will talk about this later. But right now, just let's make it very simple. Your file was converted to key value pair. This is how the key was generated, and this is how the value would be. Okay. Now, this map method is a loop. This map method would be called within a loop. Okay. And every time this map method will pick one key and one value. Okay. So for the first time, so see here, as per my input file, this map method would be called 3 times. This map method would be executed 3 times. Okay. First time your key would be 0. Okay. And second time this V would be apple, ball, and apple. This V would be apple, ball, apple. Now what you should do is you should basically convert that into a string. Okay. So you will just say, I got this V and I will convert this to a string. So when you do this, it will be converted to a Java string line. So I got this apple, ball, and apple. Now the next thing is I have to understand how many words are there, which means I have to split them, right? So you should split them by what? Space. You should split them by space, right? So I'll say line dot split by what? Space. And when you do a split by space, what you get is an array. So I can say I got a string data array. I got an array, right? So I got here an array, and this array has 3 words, apple, ball, and apple, right? So you got an array out of this, apple, ball, apple. You got apple, ball, and apple array. Now what you need to do is you need to iterate this array, right? You need to iterate this array. You'll say for string word of data. So you'll use this iterate, you'll use a for loop. Okay, you can use any for loop. For I equal to 0, I is less than equal to data dot length, and so on. So that also can be done. So anything can be done. So I'm iterating through this array. First time my word would be apple. And what I'll do is I'll say I have this context here, right? So I'll say context dot write this apple, whatever I got word and one. That's what I do. Okay. So you will say I got this data apple ball apple. I want to emit that word and one every time. Okay. Now having understood this, what is going to happen is, let us see, I was just trying to give you some understanding on how are we going to write the code, but the real code we will see it in the coming days. Okay. So when you do this, what it is going to do is it's going to see, when you say context dot write, that means output from the mapper. Okay, context dot write will be always an output from your mapper. So can I say something like this? For this line 1, I had apple ball apple. This was my line 1, right? Line 1. For my line 1, I had apple ball apple. What is the output I emitted? I emitted apple 1 ball 1 and apple 1. Can I say I did this for the first line based on this logic? Because here, as I said, this map method would be called 3 times. First time I got apple ball apple. What you did, you splitted them by space. You got an array and you started iterating through that array, and you said for the first element, for the first apple, I'll say apple 1. So apple 1, ball 1 and apple 1, done. Second time this map would again be called for this lines, next line. Next line has only apple and apple. So what you are doing, again, you are converting that to string. You have splitted them. You got an array. This time this for loop will iterate 2 times and you will say apple 1, apple 1. So for the next line, line 2, what you have? Apple and apple. And what are you going to emit? You are going to emit apple 1, apple 1 for line 2, right? Now again, you have line 3, ball, right? So you have a line 3 ball. So this map will be again executed for line 3. And this time you converted v dot to string. Then what you get is you get just a ball. You are saying line dot split of space. What you get? Only ball. And then this for loop will iterate for 1 time, and you're saying ball and 1. So for line 3, you had ball, and what you did is you just said ball 1, right? So can we say that what we did is we converted our line into key value pair after your mapper code? See, before the data comes to your mapper, it was automatically converted into key value pair by the framework, right? But then what you did is your mapper started emitting the data in form of key value pair. You said apple 1 ball 1 apple 1 apple 1 ball 1 apple 1 and so on, right? So that's what you did, right? So I hope you understood what a mapper is doing here. Mapper is converting anything into a key value pair. Now what we will do is, what would have happened if you had 2 files? If you had 2 files, then eventually that would have also given you the same thing, is not it? But we will talk about the 2 files later. Okay, let's concentrate only on 1 file. Forget about the code. We will revisit that code again. We'll write it, with our magical hands, right? So we'll write it. We'll write that code in the next lesson. But then what we understood now is, I'll even remove this because we understood what exactly we were trying to do, right? So I'll even remove this, and what I have is only this word1.txt. So I've explained you what exactly happens, but then let us try to directly write it. Okay, so this was converted into what? Now I can easily say the first line was converted to apple 1 ball 1 apple 1, the first line. The second line was converted to apple 1 and apple 1. The third line was converted to ball 1. This is what it does. Okay, done. Now once your mapper code has executed all this output, right, what needs to be done is this has to be mixed together. Why it has to be mixed together? Let us understand. Okay, see, in a typical real world, you will have a lot of nodes. 1, 2, 3, 4, 5. Let's say this is a 5-node machine. Okay, and I'm not talking about the masters. When I say 5 node, I'm talking about the slave nodes. These are all data nodes. And say you had a file, one file, only one file, word1.txt, right? And let's assume this file has a lot of lines, right? So let's say this file size is 1 GB file. If this is 1 GB file, don't you think this will be divided into a block of 128, which means 8 blocks? Yes, this single file will be broken down into 8 pieces, 8 blocks, right? And few apple ball, like it will be like this: apple ball, ball, whatever. Again, apple ball, and so on. apple ball, and so on. Other words can also come, but we are just sticking to only apple ball, right? Likewise, the file would be there, right? And then this piece would be here. This piece would be here, probably, right? This piece would be here. This piece would be here, and so on. This whole 8 blocks would be divided into this 5 machines, right? Now, when you are running your program, see here, you have block 1. Let's assume block 1 is here, block 2 is here, block 3 is here, block 4 is here, block 5 is here, block 6 is here, block 7 is here, right? And block 8 is here, let's say. So you had 8 blocks, and all these blocks are distributed in this way. And I'm not talking about replications here, okay? Now, when you run your program, mapper code, if you remember, I told you that anytime you run your MapReduce job, your business logic travels to the data. Can I say that my mapper code is here, 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 here? Yes, right? Or of course, the reducer code would also be there, but then let us just stick to mapper now. So our mapper codes are all here. Now what it will do is, it will start processing that logic, what we talked about, right? Like take each line, split them, and for each word, emit apple 1, ball 1, apple 1, ball 1. That would be done here, 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 for all these blocks, right? So in this case, I have 2 blocks, B1 and B7. So what will happen is, 2 mapper object would be used, and both of them would start working parallelly. Why? This machine has probably 8 cores. Okay, this machine has probably 16 gigs of memory, right? And then it will not process one by one. It will try to process them as parallel as possible. So so B1 and B7 would be processed together on this machine. Okay. Similarly, B2 and B6 would be processed in this machine. B3 and B8 would be processed in this machine. B4 would be processed in this machine. B5 would be processed in this machine. And at the end of the day, all this B1, B7 output would be what? Apple 1, ball 1, apple 1, ball 1. Let's say this is the output of B1. Let's say. Okay. Again, B7 output would be apple 1, ball 1, ball 1, and so on, right? So similarly, B2 will also give some output. B2 will give you some output like ball 1, apple 1, and so on, right? So everybody would give you some output. Now this output has to be mixed together, brought together, right? So once your mapper output is given, what will happen is, all this data would be mixed, and we call it shuffle. So all this data would be mixed together in a single machine. So the output of mapper, this, all these things may go to a single machine, wherever, right? And all these things would be collected together. Okay, and we call this shuffle phase. So your input file was given to mapper output was given to shuffle. Okay, you have one more thing called input formatter. I'm not talking about that right now. Okay, so just ignore that for the time being. Okay, so your input went to your mapper went to your shuffle phase, where the data was all mixed together, right? So once the data is mixed, shuffle, after that what should happen? The data should be sorted. Okay, so see, shuffle means what? Bringing them all together in a single machine all together. Okay, now let's say all these things are brought to a single machine. Now you will have the data like this. You'll have the data like this: apple 1, ball 1, apple 1, ball 1, because you are bringing the data from so many places and so many places, right? So all the data would be brought together like this, right? This is what shuffle phase will do, right? After this shuffling happens, what happens? This data would be sorted. Then this data would be sorted based on what? Key, sorted by key. So if the data would be sorted by key, how the data would look like? The data after sorting, it will be like this. After sorting, the whole data would be like this: apple 1, 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 ball 1, ball 1, okay, ball 1, ball 1, ball 1, ball 1, and so on. Okay, all apple will be first, and then followed by ball, then followed by cat, then followed by dog, and so on, right? The data was shuffled, and then the data was sorted. So input went to mapper output went to shuffle. After shuffle, the data was sorted. So once the data is sorted, all you get is apple 1, apple 1, apple 1 first, followed by ball 1, ball 1, ball 1, and so on, right? Done. Now after this sorting happened, after that the data would be grouped. After that, the data would be grouped. So how the data would be grouped? So this data is sorted. Now this data would be grouped, right? So this data would be grouped by key. This data would be grouped by key. And how the grouping will happen? Grouping will happen like this. A is a group key, B is a group key, right? What are all the values of A? Ones, right? So 1, 1, 1, 1, 1, 1, 1, like this. This grouping will happen. Okay, so your whole A was grouped into a lot of ones. So A is a group name, and all these values 1, 1, 1, 1, 1 would be in an array, right? Similarly, B would also be grouped in an array, right? So likewise, all your apple would be grouped, all your ball would be grouped, all your cat would be grouped, and so on. Done. So once this is grouped, then it's time to process this data. Okay, so input to mapper, mapper to shuffle, shuffle was sorted, and sorted data was grouped, and now we got two groups, right? So if you look into this example, as per this example, how many group it will be created, guys? Only two group, because you have only apple and ball, right? So if I don't talk about too much of examples, now if I just stick to only this data, right? So can you tell me how the data would be grouped? You will have apple here, right? And you will have a ball here. Okay, how many apple you have? 1, 2, 3, 4. So 1, 2, 3, 4. How many ball you have? 1 and 2. This is how the condition of apple and ball would be after your grouping, right? So once the data is grouped, the data has to be processed again. For that, we will have a reducer. Okay, so we know that mapper was executed on all these blocks, right? Mapper were executed on all these blocks, and since I had 8 blocks in 8 different places, mapper were executed. Okay, now after doing all these things, I just have only two groups. Okay, so if I have only two groups, then what will happen? A reducer would be used to process these groups. Okay, and by default the total number of reducers would be 1. You can definitely increase that. Okay, that means one single reducer will process this data one by one. Okay, so now what will happen is, if in any of this machine wherever the mapper was executed, probably the reducer would be used here. Okay, probably the reducer will be used here. So what will happen? All this data which were shuffled, sorted, and grouped by will travel to this place. And from reducer point of view, the reducer is going to get these two data, right? That means the reducer is going to process two groups. Okay, hence if you are writing a reducer code, let me just write some reducer code here. So in case of reducer is also a Java program. Okay, so you will write your reducer wherein you will have a reduce method, and this reduce method also takes key and value as well as the context. And what would be the key? The key would be this apple. What would be the value? Value would be this whole array. So remember, in case of your mapper code, the key was that 0 numbers, right? And the value was the whole line. Is not it? And if I ask you how many times the map method will be called for this particular file, your answer would be 3, because there are 3 lines. 3 lines, so map method would be called 3 times, right? Now, if I ask you, can you tell me how many times the reduce method would be called for this file? 2, because there are only apple and ball, so definitely there would be only 2 groups as per our logic, right? So reducer would get key, and key would be apple, and value would be this whole collection, right? Now what you need to do is, you will have to just say v, iterate this v, and then get the count of this v. Okay, I'm not writing the exact code right now, but then we will see that as we move on with the program. So you will say count the total element of v. So probably you will do something like this for int I of v. Okay, and you'll say sum equal to 0, right? Int sum equal to 0, and you will say sum is equal to sum plus I. Sum equal to sum plus I, and that will help you to add all these numbers 1, 2, 3, 4, right? So 1 plus 2 plus 3. So 1 plus 1 plus 1 plus 1 will give you 4 altogether. So at the end of this, what you'll have is, when you got k equal to apple, the value was 1, 1, 1, 1, and sum would be 4. So apple and 4, and that is what you will see. You still got this context object here, right? And then context object means give me the output. So you can say context dot write, and when you say context dot write, apple of 4, then it writes this data to the output. Apple count is 4. Similarly, second time the key would be ball. Okay, ball, and I have nothing to do with this ball right now. All I care about is this count. So v, again I'll start iterating. Sum is again 0. Again I'll start iterating, and v value would be what? 2. Sorry, the sum value would be 2 at the end of the day, right? So now next time it will write context dot write, this k would be ball and this sum would be 2, right? So you'll say context dot write k and sum. So when you say k and sum, first time it will write apple and 4, second time it will write ball and 2. And that's how the final output would be the output from reducer output. The reducer output would be apple 4, right, and ball 2. That's how basically your MapReduce program will give you the output in a very simple term, right? So it is very important to understand this word count example. Many people don't take it so seriously, and I have seen them struggling like hell. They're not able to get into this big data job. The reason is because the concepts are not clear, right? So it's very important that you understand this very, very thoroughly. Write it down on notebook, try to practice. You should understand how the data is coming to mapper, what is the mapper doing, what is the output from the mapper, and what happens in the shuffle, how the data would be sorted, and how the data would be grouped by, and how the data would go back to the reducer. So if you understand this, practically you're able to write this, then trust me, you'll be able to solve a lot of problems. That's the power of this word count example. It's very, very important. Every good book teaches you word count at least, right? Because that's the base. This is the hello world example for any big data developer.